Welcome to July 2nd's LeetCode challenge. Find k closest elements. Given a sorted integer array, two integers k and x, return k closest integers to x in the array. The results should be sorted in ascending order. An integer a is closer to x than integer b if the absolute difference between a and x is less than the absolute difference between b and x, or that the absolute difference between a minus x is equal to the absolute difference of b minus x, and b is less than a. So these are just some math terms for you guys there. So we're given this array here, and we want to find k closest integers to x. So x is right here, and we want to find four numbers that are close to it. So if you see by this definition here, they'll take 2, and you go to the right of it, you take 4, and then you go to the left of it, you take 1, then you have resulting 4. You see how like they're more, I guess, favoring the left side, because if you have for instance x equals to 3, you have one number on this side, and you have two numbers on this side, which equals to 4, but that has to do with the balance of it, and that's important to keep in mind for now. So for instance, if you have, let's say x is equal to -1, and you have 4 here, find 4 values that are closest to -1, which should be anything, basically pretty much 1, 2, 3, 4. So let's kind of think of a way to solve this. Let's I'll give you an example here. Say we're given the array 1, 2, 2, 3, 4, 5, 6, 7, 8. Alright, and let's say that k is equal to 5 and x is equal to 4. So we want to find 5 of the k, we have 4 here, and we want to find 5 elements that are closest to it, which would be, if we do that intuitively, it would be 2, 3, it would be all this number, 2, 3, 4, 5, 6. Alright, so how will we go about solving this? So there's one solution, it's using a binary search with a sliding window. So let's say that you are, for instance, you want to find 5 closest element to 4. So the thing you would do is do a binary search to find the closest element to x. So x would be, you do a binary, you could use the bisect function here to find 4. So I'll make a pointer there. There. Oh. So you find 4. Next thing you want to do, you want to define a sliding window to the with 2 pointers. So you have one pointer here, and then one pointer to here. Let's see. So now you have, 4. Now you have your left pointer as well. Next thing you want to do is you want to find, so you know that 4 is closer to x than 3, because 4 is the answer we're looking for. So now we move to the right pointer. So we're going to move this pointer now over this side. Now we have 5. So we're opening up a sliding window using a binary search. So we want to prioritize the small numbers with equal distance, because we want to make sure that we're going to the left side. We're prioritizing that left side. So the next thing we're going to do now is that we're still, our k value is still 5, right? And we have 3 values at least. Next thing we want to do is move our left pointer. So we're going to do that right here. Oh, move it to 2, and this stays at 5. And then we're still within our bounds, and then we still need more, so we're going to move our right pointer to 6. So now we have 5 values, with 4 being in the middle. Then we have all 5 values, so we just take all these numbers and we return those. So that's using a binary search with on top of a sliding window. Let's kind of let's find a way to make a solution for this. Alright, the first thing we want to do is define our base case. So if the length of our array is equal to k, then what we want to do is we want to return the array. That's pretty much if our element has k as in the array, then we just return if the number of elements we're looking for equals the size of the array, then we just return the entire array. That's pretty much our base case. So next we want to find the closest element and initialize our 2 pointers, left and right pointers. So it's called left. So in order to do that, our left pointer, we're going to assign that to the middle, or the number that we're looking for, which is at x. So we're going to use our function called bisect left, of using it on the array at x. And then we want a -1. Remember to keep it with within our the numbers that we're looking for exactly. And then we want to develop our right pointer, and that's going to be left -1. Oh, +1, I should say. So we have a left pointer and a right pointer now, which has been initialized. So while now we have a left and right. Now we have a window. While the window size is less than k, we're gonna start to grow. We're gonna develop that right now. So while the window size, or right minus left, -1 is less than k, what we're gonna do is we're gonna do if the left is equal to -1, because if our left pointer is -1, then what we're gonna do is assign right to be +1, or incremented 1, I should say, and then continue. So what we're doing here is that while the window size is less than k, we're gonna move our right pointer, being careful not to go out of the bounds. So we have one side going on, and then we want to expand the window towards the side with the closest amount of number. So we want to expand the window now. So how do we do that? And also remember to stay within our bounds. So if the right is equal to the length of the array, or the absolute value of the array of the left side is -x, is less than or equal to the absolute value of the array from the right side. Oops. Minus x as well. Was it? Yep. Minus x. Then we want to do left. Oh, what the? Let's see. Right, left. I see. There you go. Then we want to do left decremented by 1, because we want to move the pointer backwards to the left side. Else what we're going to do is increment our right pointer to the right, incremented by 1. So once we keep on traversing through or expanding our window, what we're going to do is once we're done all that, we're going to return our window. So return the array where array of left +1 to right. Alright, let's see if this works. Run the code. Alright, it looks the same. Alright, accepted. So pretty much we start with the array in the middle, and then we'll find x, and then we just expand our flying window left, right until we reach k, and then we just return everything inside. It's pretty straightforward. Time complexity is big O of log of n plus k, because the initial binary search to find starts the initial, like, this function right here starts off to find the window, costs us a big O of log n times, and then by sliding the windows left and right, it costs big O of k times, so it'll be big O of log n plus k, pretty much. And space complexity is big O of constant space because we only use integer variables to keep track of our left pointers and our right, left and right pointers. So regardless of the size input, so the space used is constant space. Yeah, that's pretty much it for this solution. However, there's actually a very clever solution right here that I'm just gonna hopefully. No, that's actually it for today. There's another solution called like binary search to find left bound using midpoints, which is super clever and super nice and short, but it would take a lot to explain. So that'll be a bit for today. Have a good one, guys.